Hello, I will be presenting Fluvial sequencing and Caddo Landform Modification at the Crenshaw Site by myself, John Samuelsen, and Margaret Guccione. Understanding the geomorphology of archaeological sites is useful for determining how the surrounding landscapes change through time, informing us of how these changes affected the ancient inhabitants of the preservation of the sites themselves. River migration can completely erode entire landforms. New landforms are deposited behind the migrating meanders, leaving no trace of the settlements and people that may have existed in the past. Understanding the changing position of a river channel over time may reveal locations where undiscovered sites, especially buried sites, may be found. It also may enable archaeologists to determine the position of the river at the time of occupation and improve our knowledge about the ecology of the landscape at the time of occupation. These studies can also aid in understanding the extent of past human occupation in space because areas that have been destroyed by the river can create abrupt modern site boundaries. If cultural materials are found near these boundaries, it might indicate that parts of the site have been destroyed by past river action. The Crenshaw Site, located along the Red River in southwest Arkansas, is a multiple-mound Caddo ceremonial center of great significance to the Caddo and archaeologists. The Caddo and their antecedents occupied Crenshaw between at least 900 and 1400. The site had 6 mounds, A through F, at the time of C.B. Moore's 1912 test excavations. While mounds A and E remain mostly intact today, mounds B, C, and D have been excavated or destroyed, and 3 trenches have been dug through Mound F. Several oxbow lakes and linear or curvilinear depressions exist around the site, making it difficult to determine which partially infilled channels was the river's location during Caddo occupation. This study will analyze all known abandoned channels that surround Crenshaw and use historic documents and maps, lidar data, and subsurface core information to test which, if any, of the oxbow lakes or depressions west of the site may have been an active Red River channel or an oxbow lake during site occupation. Additionally, the location of the site relative to various younger channel positions help assess how much of the site has been destroyed by river action. This provides information about Caddo sediment patterns through the study of the spatial extent and temporal lengths of the ancient Caddo occupation, the nature of ritual or domestic use, and how the Caddo interacted with their environment. The Red River Valley in southwest Arkansas includes locally preserved Pleistocene terraces that flank a broad Holocene floodplain cut into tertiary uplands. Near Crenshaw in the Great Bend region of the Red River, the 20-kilometer wide Holocene floodplain includes a 4.5 kilometer wide active meander belt on the east side of the valley, with most of the back swamp lying on the west side of the valley. Crenshaw is preserved in the west side of the meander belt. Past geomorphological studies and previously hypothesized channel locations for Crenshaw enable construction of testable hypotheses. Charles Pearson conducted a geomorphological study of the Red River in the Great Bend region and identified fluvial landforms that were younger than 1580 based on the location and fill of meander scars in an 1887 survey map. Schambach proposed that the low topographic area just west of mounds A and E as the location of the active river at the time of site occupation. This study seeks to test this hypothesis. Crenshaw is separated from the present channel by a recently constructed levee to control flooding. There are at least 2 modern oxbow lakes near Crenshaw and west of the present Red River. There are also several other linear or curvilinear depressions that may represent an active or abandoned channel during site occupation. Because the Red River currently is east of the archaeological site, it is possible that the river migrated across and eroded part of the site when a western channel was abandoned. Alternatively, if the river avulsed or moved due to the active channel being cut off to a new eastern location without migration, all or part of the site could be preserved. Historic maps and aerial photographs were collected and analyzed to establish a timeline of river meandering and subsequent abandonment of river channels that became oxbow lakes. The landforms associated with oxbow lakes can be relatively dated using cross-cutting relationships. Combining this information with known site locations and their estimated date ranges confirmed the estimated landform age, as done by Pearson in this region. This information was combined with lidar data around the site to better identify topographic anomalies related to fluvial events. Crenshaw is southeast of the first Old River Oxbow Lake and north of the second Old River Oxbow Lake. Based on cross-cutting relationships, the archaeological site is located on a landform older than both of these abandoned channels. Maps from 1842, 1864, 1887, 1912, 1929, and 1936 and the survey for the Miller County line in 1874 support the age estimates of First Old River forming between 1887 and 1912, and Second Old River forming between 1842 and 1864. This is long after the Caddo left Crenshaw. In addition to maps, aerial photographs show the path of the river channel since the 1940s and the areas which have since been eroded by the river. Parts of Crenshaw and any satellite sites that might have existed along these meander paths would have been destroyed by the river to the south, northwest, and east. Historic maps, aerial photography, and lidar depict a more complete river meander sequence with their estimated ages. This analysis identified depressions of partially infilled abandoned channels, 7 and 8, that were not previously recognized by Pearson. Thus, it shows additional areas that may have been destroyed by the river since the Caddo occupation at Crenshaw, and channels that may have been active or abandoned to form an oxbow lake at the time the Caddo occupied Crenshaw. Identification and relative ages of channels 7 and 8 are based on the cross-cutting relationships and degree of fill evident on lidar, providing better time resolution than previous studies. A land survey in 1840s and an 1864 drawing and an AHTD map from 1929 show the remnants of channel 7 in the form of an oxbow lake. An on-site survey of the location confirmed the identification of channels 7 and 8. The current river has also eroded the eastern side of the meander belt at the latitude of Crenshaw as recently as the 1960s. Most of the floodplain east of the river near Crenshaw is young, precluding satellite sites from being found east of the river. However, there are small portions that have been undisturbed by historic meandering, as evidenced by 3HE12 and 3HE14, two mounds that have Fluvial or Caddo cultural affiliations. On the northern portion of Crenshaw, no obvious meander landforms are present, and thus the site could extend north to the modern channel. A geophysical study found many archaeological features in this area. A shovel test survey in the area by Kelly and Cox found midden and Caddo artifacts. Extension of the site to the north is also supported by a written sherd found in Crenshaw Course 17, buried within a midden at 172 centimeters below the surface. To the northwest of Crenshaw, the meander that created First Old River destroyed any archaeological material that may have been present. The western edge of the site is known to continue at least to the vicinity of Core 37, where geophysical anomalies were found. There have also been reports in the Arkansas Archaeological Survey site files of Guccione material in fenced post holes nearby. South of the site is Second Old River, or Channel 5. If the ancient site had extended in this direction, it would have been eroded. This leaves a narrow area just southwest of the site that may still contain cultural material, though artifacts may be buried by natural levee deposits of Channel 5. Clearly, there are significant portions of the site that have not been eroded and have been buried by younger river sediment, making identification of the exact site boundary difficult, but the preserved site is estimated to be 60 to 75 hectares in size. Two depressions west of Mound A suggest the presence of at least one abandoned channel near the site. The eastern depression is deep and wide and may be in part a burrow pit for Mound A. The western depression is considerably narrower and less continuous. These two depressions merge to the south near the location of Core 3. 5 soil cores were taken in a transect near and within the suspected abandoned river channel west of Mounds A and E. The cores were sampled with a Giddings soil probe drilling rig. Cores were used for sediment description, sampling, and grain size analysis. 30 selected soil samples from the cores were used to quantify the textures estimated in the core descriptions. A combination of lidar data, cores, historic maps, and excavation data establishes that 4 channels are present west of Mound A. Furthest to the west are First Old River and Channel 7. First Old River is younger than the Caddo occupation. There remains a possibility that Channel 7 was active at the end of the Caddo occupation. 2 channels west of Crenshaw have been mostly filled, Channel 8A, or partially filled, Channel 8B. These channels can only be traced a short distance because they have been eroded to the south by Second Old River and eroded or buried to the north, so they are not visible on the landscape. The 2 channels merge to the south and are interpreted to be part of the same meander bend. Channel 8A appears to be the furthest west position of the Red River for this meander bend as it migrated to the west. While this meander bend was still active, a chute channel cutoff formed on the meander bend, and the main channel shifted from channel 8A to channel 8B. After the shift, channel 8A experienced limited flow and filled with bedded sediments as channel 8B became dominant. Eventually, permanent abandonment of the inner channel, channel 8B, by a neck cutoff somewhere to the east allowed the channel 8B to become an oxbow lake and slowly fill. Some of this fill was utilized by the ancient Floodplain or Caddo for the adjacent Mound A construction. Channel morphology can be reconstructed using lidar and stratigraphy along the core transect. Fill in channel 8A was at least 5.7 meters deep and may have been up to 140 meters wide. Based on both lidar data and the sediment exposed in core 3, channel 8B is estimated to have been approximately 5 meters deep and have been more than half filled with oxbow lake silt and clay. The base of channel 8A is at least 3 meters below the present abandoned channel surface, and the present topographic depression is approximately 2 meters below the surrounding surface. Based on lidar data, channel 8B is at least 80 meters wide. Both channels 8A and 8B are narrower than the modern channel, or recently well-preserved abandoned channels that are 250 to 325 meters wide. It is possible that the bar at core 35 between channels 8A and channel 8B is a mid-channel bar, separating two branches of the channel, and the outer channels died as the inner channel became dominant. The full width of channel 8 in that case would be approximately 220 meters, more consistent with the modern channel width. An unexpected but important result of the lidar data analysis is that the depression west of Mound A, previously thought to be a burrow pit, is most certainly purposeful landscape modification by the ancient Caddo. Beyond the construction of the mounds, the causeway, and the burrow pits, the Caddo or the antecedent Floodplain appear to have modified the edge of the oxbow lake that existed west of Mound A. The rectilinear patterns in this area do not form natural geomorphological features. Instead, it appears that this area was modified to have rectilinear topographic features, while also being used to construct Mound A. These results are also supported by rectangular anomaly with a central area of high magnetism and geophysical data corresponding to the elevated rectangular area. While the shape is likely the result of taking sediment from the construction of the mound and causeway, the resulting rectilinear pattern represents the Caddo purposely excavating from specific areas. All of this landscape modification shows that the Caddo were not just inhabitants in their environment, but were actively modifying their environment according to their ritual or ecological designs. The Caddo's modification and use of this area as a burrow pit also suggests that this was an abandoned channel and not an active channel at the time it was modified and Mound A was constructed. This is because this modified shape would not have withstood the water movements of an active channel. In addition, the burrow is deeper here than the area around it, suggesting that channel fill was excavated after the channel was abandoned by the river. The human activity in Crenshaw Core 5 and a geophysical survey both confirm the use of this area by the ancient inhabitants. The top meter of Crenshaw Core 5 on the adjacent point bar landform is darkened by human activity. The over-thickened A horizon and biodepression of this horizon made it difficult to find stratigraphic boundaries and suggest minor accretion of the surface during human occupation. In addition, quartz appeared in the gravel fraction of the uppermost sample, suggesting the presence of microdebitage in the area and therefore human occupational debris. Because Mound A and the causeway are on a point bar of Channel 8, it is impossible for them to have existed prior to its migration across the site. Therefore, Channel 8 migrated to the west before it was cut off, forming an oxbow lake. It was only long after that the point bar was formed, the channel was cut off, and fill accumulated in the lake that the Caddo constructed Mound A and the causeway from the adjacent burrow pit material of channel fill. This also implies that they similarly constructed Mound E after the oxbow lake formed. While Schaumbach's suggestion that the river channel was active when the Floodplain or Caddo occupied the site could still be true for the earliest portion of the occupation, it appears that, at least when the Caddo were constructing mounds, the active channel of the Red River was to the east. Schaumbach's map also shows the water flowing eastward in Second Old River's location. However, it is clear from the historic records and lidar data that Second Old River was later in time and that the water flowed westward. This is important because it means that unknown portions of the site were likely destroyed as second old river migrated across the southern portions of Crenshaw's landform. The current understanding of the site needs to consider the possibility that part of the originally inhabited landform was destroyed prior to Moore's site map. Crenshaw's Skull and Mandible Cemetery and an ash bed structure were excavated near Second Old River, indicating that the ancient Caddo occupation extended up to the current location of the Oxbow Lake. This is also confirmed by a geophysical survey. Therefore, our understanding of the timing of occupation and ritual domestic use of the site may be distorted by preservation factors. Previous studies and multiple pieces of information analyzed in this study all point to the Crenshaw site extending north, probably to the recently constructed levee. This includes evidence that the northernmost areas are deeply buried by younger river sediment in core 17. This provides some support for the hypothesis that the northern linear raised feature is an ancient causeway rather than an artifact of an old fence line. The information obtained from the Fluvial sequence analysis, lidar data analysis, and analysis of core transect adds to the geomorphological knowledge of the area as previously explored by Guccione and colleagues and Pearson. There is little evidence that any Holocene Red River meanders exist west of channels 7 and 8 and the first and second old rivers. This bolsters Guccione's definition of the boundary between the meander belt and the backswamp area. This study tested the hypothesis that the low areas on the west side of the Crenshaw site were abandoned Red River channels at the time the Caddo occupied the site. The results suggest that channel 8A filled relatively rapidly as some water flowed through, but channel 8B was abandoned and became an oxbow lake. Partial filling of the lake occurred before the Caddo constructed mounds. Based on this information, the Red River has been east of the preserved portion of the site since the time of the construction of Mound A. It is possible, if not likely, that significant portions of the occupied landform were subsequently destroyed by migration of Second Old River. Although less clear, Channel 7 may have also eroded portions of the site to the northwest. Other areas of the site to the north are buried by overbank sediment. Therefore, our present understanding of the size, population, and timing of the occupation may be distorted by preservation factors. The analysis shows that the Caddo actively engaged with their environment. Beyond building mounds, they modified landforms according to their designs. The combination of the rectilinear modification of the landscape along the abandoned channel and the construction of causeways shows that the ancient Caddo at Crenshaw designed landscape features unrivaled elsewhere in the Caddo area and much of the southeast. This information, combined with the unusual ritual activity and extensive occupation documented by archaeology and geophysics, shows that Crenshaw was a location that had great significance to the ancient Caddo. I'd just like to thank all those who helped this study. Of course, my co-author, Dr. Guccione, and many of the students that helped along the way taking course at the site, the land owners who graciously allowed us to do the study, Larry, Judy Head, Joyce Nottingham, Brandon Wren, and then, of course, the Caddo Nation of Oklahoma. And then special thanks to Jamie Lockhart, who helped by processing and supplying the LiDAR data. So thank you very much.